Sum and difference formula, section 5.2. We're going to see in this section, if we have two angles, how do we find their sine, cosine, and tangent? How do you find their sum, the sine, cosine, tan for their sum and their difference? So let's start with cosine. So if we are given two angles A and B, what is cosine A plus B? I'm not going to prove the detailed formula out of this, but I'll state it and show you how to apply it and why we're learning this. Cosine A plus B. Some people might think this is simply cosine A plus cosine B. Well, this is not true at all times. It might work in specific cases, but not all the time. Well, then, what's the formula for this? Well, the formula for cosine A plus B is given by cosine A cosine B minus sine A times sine B. That's the formula. Is there one for minus cosine A minus B? Yes, it's the same formula. The middle sign gets switched. Instead of minus becomes plus. So if this is plus, this is minus. Minus plus for cosine. Some people like to abbreviate as cosine starts with C and C. So CC minus SS. CC minus SS. Or C square minus S square, to make it easy for them to memorize. How do we apply something like this? What about if someone asks you find the value of cosine 105 degrees? How do I find this? Well, I don't know if, even possibly if we draw the unit circle and try it there, it might be a little bit still difficult. But what I do, I'm gonna write 105 either as a sum or difference of two angles that we know their sine and cosine. And those angles that we covered in previous chapter, for example, the well-known angles that we use, 30, 45, 60, 90, 135, and so on and so forth. But the acute angles are those ones, 30, 45, 60. Those are the ones that we use the most when it comes to the first quadrant angles. So in this case, I think 45 and 60 will do it. And the formula said cosine, cosine. Switch them into sine, sine, sine. What's cosine 45? If you remember the table we covered before, is radical 2 over 2, and this is cosine 60 is 1/2 minus, again, square root of 2 over 2. Sine 60 is the square root of 3 over 2. Now we simplify. If you multiply the top by the top, bottom, bottom, minus top, top, bottom, bottom, the common denominator is 4. So that leaves square root of 2 minus square root of 6. That's how we find cosine 105 without a calculator. What about cosine 15? Again, we need to think about two angles. Their sum or difference is 15. 15 is already a very small angle here. So maybe think about, instead of sum, think about a difference. Maybe I would go 60 minus 45. Or 45 minus 30, either one would be fine. And then this is cosine, cosine, plus sine, sine. So cosine, cosine, plus sine, sine. And what does that give us? This is square root of 2 over 2. This cosine 30 is square root of 3 over 2 from the table. This is square root of 2 over 2. And this is 1/2. Let's see, we got square root of 6 over 4 plus square root of 2 over 4. So that gives us the square root of 6 plus square root of 2 over 4 as an answer. Now, what about if someone asks us to simplify? Simplify something like cosine 5x cosine 2x minus sine 5x sine 2x. This looks like the right hand side of the first box formula. Cosine, cosine minus sine, sine. So we can go backwards, means go to the left side and write as cosine A plus B. So here, this is like A, this is B. A again B. So cosine, cosine minus sine, sine. That's cosine A plus B, because you have to switch the sign. Again, A is 5x and B is 2x. So that gives us cosine 7x. So this whole the entire expression gets simplified down to cosine 7x. The next question that we need to answer, is there a formula for sine A plus B and sine A minus B? Is there a form for A sine A plus B? The answer is yes. It's simply sine cosine, so sine A cosine B, plus cosine A sine B gets switched. And for sine A minus B, same formula. Sine cosine minus cosine sine. Notice, I'm gonna box both of them at the same time. Notice the middle sign, they must match in the case of sine. And then you can memorize as SC from the first letters, CS. So SC, CS. SC, CS. So this is, or these are the forms for the sine, the sum and the difference. And how can we apply this? Let's look at a slightly different example. Let's prove this one. We gave this to you before without proving it, but we can prove it now using these formulas. We start with the left hand side, rewrite it. What's sine A minus B? It's sine A cosine B and minus cosine A sine B. What's sine pi over 2? It's 1 from the table. Cosine pi over 2, 0 from the table. This is cosine x. So that proves what we need. Another example, maybe simplify sine 7x cosine 2x plus cosine 7x sine negative 2x. This looks like sine A cosine B plus cosine A, but sine negative B. So that negative sign here, it bothers. How can I make it, what should I do with that sign? Well, the first thing we do is rewrite this the same just to take care of that highlighted sign. Keep cosine 7x the same. From the previous section, when we learned about even and odd identities, sine is odd. So sine negative 2x is negative sine 2x. It's kind of like you take the negative out. Negative sine 2x, because sine is an odd function. Now they match. As you can see, 7x and 2x match. So then we use the formula sine A minus B. A minus B, because the sign here, this sign and this, they must match. So what do we get? We get sine 5x as the simplified answer. Let's look at a slightly different example. Let cosine A be negative 7 over 25, where A is in quadrant 3, and sine B 40 over 41. B is in quadrant 1. Find sine A minus B, cosine A minus B, and from also we're gonna find tangent A minus B. Now, how do we start with this one? To start with this one, let me write down the formula first. Sine A minus B. We said it's sine A cosine B minus cosine A sine B. Let's see what is given. Do I know sine A? No. Do I know cosine B? No. Minus. Do I know cosine A? Yes. Negative 7 over 25. Do I know sine B? Yes. 40 over 41. Now, how do we find sine A and cosine B? We can use the Pythagorean identities or SOHCAHTOA. So cosine A is 7 over 25. So I'm going to draw a right triangle. This is A. We know that cosine 7 over 25, forget about the negative for now. Cosine is the adjacent over the hypotenuse. And it would be really nice to know what we call them, the Pythagorean triples, and I'll list some of them in a minute. 7, 24, 25 is one of them. That saves a lot of work if you know it. So from here I can find what sine A is. Opposite over the hypotenuse. Do not forget that A is in quadrant 3, so we are working here. In that quadrant, sine is negative from the previous section. All students take calculus. For B, they give us sine B is 40 over 41. You can draw a separate right triangle for that. And remember, sine is the opposite over the hypotenuse. Again, we have another Pythagorean triple, which is 9, 40, 41. From here you can find cosine B, which is the adjacent over the hypotenuse. Well, where is B? A was in there. B is in quadrant 1. So in quadrant 1 everything is positive. So now I'm going to take that line on the top and see how to simplify this. So to simplify this, first thing I always do, multiply the top ones. So we're going to multiply 24 by, so that expression is going to equal to negative 24 by 9 is negative 216 over 25 times 41. Keep it for now the same. Minus minus is plus 25 times 41. Multiply 7 and 40, 280. Now the denominators are the same. If you multiply the denominator, 25 by 41 is 1025. And now we can combine the numerators. That's 64. So it's 64 over 1025. Recall again what we call them, the Pythagorean triples. 3, 4, 5 is one of them, and any multiple of that. So any multiple means if you multiply everything by 2, that gives me 6, 8, 10. Multiply everything by 3, 9, 12, 15. And you can multiply by any number. Another common one is 5, 12, 13. That's a common one that we use. Another one is the 9, 40, 41 that we use today, and the 7, 24, 25. Those ones we use them a lot, called Pythagorean triples. So we found sine a minus b. So this was sine a minus b. So now we need to find cosine a minus b. Cosine a minus b. What is cosine a minus b? Well, let's write the formula down. Cosine cosine plus sine sine. CCSS. So cosine A, let me see, what's cosine A? It's given, negative 7 over 25. Times, let's see, what's cosine B? Cosine B is not given, but we found it. It was 9 over 41. 9 over 41. Sine A, we found it, negative 24 over 25. And sine B, 40 over 41. So notice how the denominators are the same. So which we already found the value for that earlier. So multiply top and the bottom by the bottom one. And we can do the same thing for the top one. Common denominator. For the top one, they have the same sign. We can combine them by adding that. And that will give us cosine A minus B. Cosine A minus B. The next one, the last one, they ask us to find tangent A minus B. Tangent A minus B is sine, you can say it's sine over cosine, as we defined it in the previous section, the quotient identity. We found sine. It was 64 over 125, 1025. And this one, we just found it. These cancel, simplified to negative 64 over 1023. Notice how we found tangent using sine and cosine. The question that someone might ask, is there a formula for this? What about the plus case? The answer is yes, there is a formula. Let me write down the first one. The formula for this is tangent A plus tangent B over 1 minus tan A tan B. Tan A tan B means tan A times tan B. That's the formula for tangent A plus B. Where did that come from? Is there a way to prove it? Yes. Let's prove it for fun. We know tangent is sine over cosine. So let's keep the left hand side the same. Today we learned a formula for sine A plus B. It's sine cosine plus cosine sine. The bottom one, cosine cosine minus sine sine. Now how do I get everything in terms of tangent? Well, let's see. So let's keep this the same. I'm going to write everything the same. Leaving some space because I'm going to divide by something in a minute. So if I want to get tangent here, I want to get everything in terms of tangent, I need a cosine A because sine over cosine is tangent. And what do I need with this? I need to get rid of it. So I divide by itself to make it 1. Since I divided that this way, I'm going to divide this the same way. And we do the same thing for the denominator, for each part or each section in the denominator. So this way, we balance the fraction. And let's see how this is going to turn out to be a nice formula that I wrote earlier. This cancel, that's a 1. Sine over cosine is tangent A. Plus, this cancels. Sine B over cosine B, that's tangent B. This cancels, so that gives us 1 minus sine over cosine is tangent A. Sine B over cosine B is tangent B. So that's the formula. Is there one for minus? Yes, A minus, or the difference. It's the same formula as above. Only the signs get changed. The minus becomes plus, plus, minus. So this sign always matches the top one. This sign matches the top one. And the bottom one is the opposite. Bottom one is the opposite. Let's look at an example on this. Let sine A be negative 3 over 5. A is in quadrant 3. And cosine B 5 over 13. Angle B is in quadrant 3. Oh, quadrant 4. Make it quadrant 4. Because cosine is negative in quadrant 3. So find the value of tan A plus B. So I'm going to use that formula, tan A plus tan B. So what I need just tan A and tan B. If I got those, I just substitute them in and simplify. Again, the easiest way is draw a right triangle and a circle. A is in this quadrant. That's where A is located. A is here. So angle A, right triangle. By SOHCAHTOA, a sine is the opposite over the hypotenuse. Remember the 3, 4, 5 right triangle, Pythagorean triples. I'm going to draw another case for the second one, for angle B. B in the 4th quadrant. That's where B is located. Cosine adjacent over the hypotenuse. Another Pythagorean triple, 5, 12, 13. So now, remember the formula is tangent A plus tangent B over 1 minus tangent A tangent B. Well, let's see, using the triangles. Tangent A is the opposite over adjacent, 3 over 4. A in quadrant 3, tangent is positive, plus. Tangent B, opposite over adjacent. B in the 4th quadrant, that should be negative. Over 1 minus, that's 3/4, negative 12 over 5. Now we simplify. 3 over 4 minus 12 over 5 stays the same. 1, negative by negative, positive. The top one is, don't simplify, do not simplify this 4 with the 12. Keep it as is for now. So it's 36 over 20. Because if you simplify it, you're going to kind of use it again, come back to it again. So here, this is called complex fraction. We look at all the denominators, 4, 5, 20, and 1. What's the LCD to all of them? You know, it's 20. This is the easiest way to kind of clean all these fractions. So we multiply the top of each fraction by 20, by 20, by 20. That's the LCD. And let's see what we get. We get by 4, 1 by 4, 5. 5 times 3, 15. Minus 5, 1, 5, 4. That's 48. 20 plus 20 cancels, 36. what do we get? 56 here, and on the top, if we do subtraction, we get negative 33. So that would be the answer for tangent A minus B. Can we look at a different example? If tangent A plus B is given as 6 and tangent B is 1/3, find tangent A. So to do so, we take tangent A plus B. The formula we just derived, and we know it's tangent A plus tangent B over 1 minus tangent A, tangent B. The left-hand side is 6. Tangent A, I'm looking for tangent A. Tangent B is 1/3 over 1 minus tangent A times tangent B is 1/3. Again, on the right side, I get a complex fraction. That's over 1, the whole tangent over 1. The LCD to all of them is 3, so I multiplied this by 3, by 3, by 3, and 3. We don't touch the left-hand side. Keep it as is, 6. We get 3 tangent A plus 1 over 3 minus tangent A. You can assume, if you like, that tangent A is x and then just solve for it. Or you can just cross multiply right away. 3 tangent A plus 1 equals 6 times 3, 18. 6 tangent A. We can add 6 tangent A to both sides. We get 9 tangent A and subtract 1. So then tangent A, that what I'm looking for, is 17 over 9. You can leave it like this, or you can write it as 1 and 8/7. We can go over more practice on this. If they ask us to prove cosine pi over 3 plus x plus cosine pi over 3 minus x equals cosine x. Make sure to apply the formulas the right way. We don't use this as cosine pi over 3 plus cosine x. No. The formula said, from the left-hand side, cosine cosine minus sine sine. Same thing here, cosine cosine, we switch the middle sign, plus sine sine. We don't touch the right-hand side. That's going to be the answer. That's the answer in the back of the book. Don't touch the right-hand side. Let's see. Pi over 3. If you think it makes it easier for you, convert it into degrees. This is exactly 60 degrees. And cosine 60 is 1/2 times cosine x. Nothing can be done here. Again, that's 60 degrees. Sine 60 is the square root of 3 over 2. Sine x, nothing can be done. I can use the same as before. It's 1/2, and this is root 3 over 2. Now we combine what we call like terms. This cancels this. 1/2 plus 1/2, it's 1. 1 cosine x. And that's what we were asked to prove. How about another one? More tricky. So prove secant A minus B equals cosine A plus B over cosine square A minus sine square B. This can be difficult to some students. Where should we start? right? That's what people say. Where should I start? Right hand side or left hand side? Now you can try to start with the right hand side, but you will find it's at some point it's not going to be easy to proceed from there. What about if I go from really the small side, which is the left hand side, and see where we can get to? We keep an eye on the right hand side. We don't touch the right hand side. That's our answer in the back of the book. But we do keep an eye on it. Keep an eye on the right hand side. So secant is 1 over cosine. Secant is 1 over cosine. What can I do here? Well, the only thing I know and I can do is just use the formula we learned today. It's cosine cosine plus sine sine. Okay, then how am I going to get to that one? Well, keep an eye on the right hand side. Look at the right hand side. What do you see on the top? I see cosine A plus B. Oh, I know a formula for that. It's cosine cosine minus sine sine. So what I'm going to do here, I'm going to multiply, keep this the same. Multiply, we had a 1 here. I'm going to multiply here by cosine cosine minus sine sine. So cosine A cosine B minus sine A sine B. If I do something on the top, I have to do it on the bottom to balance this fraction, minus sine A sine B. Now look why we did this, because the top is simply cosine A plus B. And that's what I want on the top, on the right hand side. Now I still need cosine square A and sine square B. So in the denominator, notice something. This is the same as this, and this is the same as this. That reminds us about x plus y times x minus y. This is x squared minus y squared. So we can use it here. You square the first one minus the square of the second one. Or if you forget this, it's okay, just distribute everything out. It will clean down to this one. Now, more keeping an eye on the answer. I need cosine square A and sine square B. On the side here, I'm going to write that down. I need cosine square A and sine square B. That's all I need. Well, what does that mean? Do I have cosine square? Yes, I do have it here. Do I have sine square? Yes. So this means I need to somehow get rid of these two things. Well, let's see how we can get rid of that. Keep cosine A plus B the same. How do I get rid of this? Well, I need this. I want this to stay there. Instead of cosine square B, what am I going to do? I'm going to write it as 1 minus sine square B, because I do need sine square B in there. Minus. I don't want sine square A, so I'm going to replace it with 1 minus cosine square A, because I do need cosine square A in there. And I'm going to keep that as is. Cosine A plus B. In the denominator, multiply that out. Minus cosine square A sine square B. Minus sine square B plus cosine square A sine square B. I just distribute everything out. Let's see, does that simplify it any further? Hoping we can get what we need. Notice this and this are the same, opposite, they cancel each other. The only thing left is cosine square A minus sine square B. Is that what we need? Cosine square A minus, yes it is. Again, this can be like a little bit difficult to some students, but going over the proof once and twice, it teaches you a lot of concepts. The idea behind proving identities is to help you improve on critical thinking. How do I start thinking about this? What should I do next? If I get stuck somewhere, what should I do? Can I go back and start again in a different way? One of the tricks is to keep an eye on the answer. What do I need? Keep an eye on the answer. Otherwise, you'll be writing stuff you don't know what the end of the tunnel is. Where are you heading to? So I'm heading to this blue side on the upper right side. And that's what I need. That's what I keep an eye on. So this is what this section is about. Section 5.2.